In this experiment, we're going to demonstrate that the national grid is more efficient when it's working at high voltage. The power station is modelled with a power supply providing an alternating current. The voltmeter will measure, and the brightness of the bulb will show the size of the potential difference at the input. Behind the safety screen, thin wires will model the transmission lines between the pylons. The voltmeter attached to these wires will measure the potential difference of these power lines. On the other side, a second bulb and voltmeter will again measure the potential difference at the far end of the transmission cables. Comparing the brightness of the bulbs and the size of the measured potential differences will give us an indication of the efficiency of the transmission. At the input end of the transmission cables, there is a step-up transformer that will increase the potential difference by a factor of 200. The two sets of connections allow the power supply to be connected directly to the transmission cables with no change in voltage, or to include the transformer and increase the potential difference by the factor of 200. Similarly, at the other end, there is a step-down transformer which will reduce the potential difference by a factor of 200 if it had been stepped up. We now switch on the power supply and increase the potential difference. At just over 13 volts, the bulb is shining brightly. This is then connected to the input of the transmission lines. At the other end of the transmission wires, the bulb is not shining. The potential difference has reduced to just over 1 volt. Working at low voltage, there is significant energy losses in the transmission lines. I'm now going to change the connections to include the step-up transformer and step-down transformer into the transmission system. This will increase the potential difference of the transmission lines by the factor of 200. We can now see that the potential difference of the transmission lines is over 100 volts. The output of the step-down transformer is at 6 volts, meaning the second bulb is now glowing. When the transmission system is working at the high potential difference, the energy losses are significantly less. This is because increasing the potential difference has decreased the current that's flowing, reducing the ohmic heating in the transmission wires. To demonstrate that the potential difference of the transmission wires is very high, I've connected a mains bulb between the two, which glows brightly.